Groups important. All right, and then we'll have a classwork assignment. So this is, yes, sir. What's the blue? Oh, that's just a note for me because I have morning duty and afternoon duty, and my duty ends that day, so I'm very excited. So I put it on the calendar to remind me that that is my last day of morning duty and afternoon duty. All right, so the last 3 lessons have all been graphing higher degree polynomials. What's different is how we solve for the zeros, okay? That's what's been different on them. So a lot of this is the same in behavior, y-intercepts, 3 degrees is 3 zeros, right? It's just finding the x-intercepts is what's different. All right, so like I said, this is a review. Example 1. We have x cubed minus x squared minus 4x plus 4 equals 0. Is this in standard form? Yeah, it is. Just by looking at the polynomial, we know several things about the graph. One thing we know is the y-intercept. +4, exactly. Whatever the constant is. Remember, the constant is the term that does not have a variable. So if you don't have a constant, your y-intercept is 0, okay? So if all of your terms have variables, then your y-intercept is 0. But if you have a constant, then your y-intercept is that number. DJ, do you mind getting that? We also know how many degrees there are. In this case, how many degrees are there? How many? 3 degrees. 3 degrees tells us there's how many zeros? 3 zeros. Zeros are also called roots, x-intercepts, solutions, right? But remember, only our real zeros are x-intercepts. If they're imaginary, yes, it's still a solution, but it will not be where the graph crosses the x-axis. And we also can just look at this problem and tell what our end behavior is. I'm going to call that EB. When in standard form, the very first term is the term that you look at, right? You look to see if the exponent is an odd number or an even number. In this case, it is odd number. And you look at the coefficient to see if it's positive or negative. The coefficient is the number in front of x, and that's a +1. So it would be positive, right? Again, if you still don't know how to determine end behavior, you need to go back and watch that lesson. So if it's odd, we know it's either up, down, down, up. One or the other, up, down, down, up. Even is either up, up, down, down, right? So if it's odd and positive, it's going to end on a positive note, which means it'll start on a negative note. Remember, that's how we remember it. So what is it? Up, down, or down, up? Down, up. Left side will point down, right side will point up. So we know all of those things just by looking at the polynomial. But there's something that we don't know just by looking at it, and it's critical to our graph. Even though we're just sketching it, there's a few things we can know for sure. And one of those is your x-intercepts. And the only way to find x-intercepts is we got to do the math, right on? So I've taught you this method before. If you see 4 terms, you hope you can do factor by grouping, right? 4 terms, factor by grouping, that's what you're going to say. If you see only 2 terms, well, if you have a perfect cube plus a perfect cube or a perfect cube minus a perfect cube, you're going to factor, that's the sum of cubes or difference of cubes, right? And when you use the identities, that's what we did last class. Or if you only say you have 3 terms and they all have a greatest common factor, if you factor it out and what's left is a quadratic, then we know how to solve quadratics, T-chart, divide and slide. We'll use that type of factoring. So each problem, you got to be able to look at it and say, okay, how am I going to solve this? You have to be able to answer those questions. So when you see 4 terms, you think factor by grouping. And not everything is factorable, but everything I'm going to give you will be, okay? So remember, when you do factor by grouping, you group your first 2 terms together and your second 2 terms together. You're going to factor the greatest common factor out of each set separately. So in my first group, what's the greatest common factor? 1 is a common factor. Do I have any variables? X. So x cubed has how many x's? 3. X squared has how many x's? So do they both at least have 1x? Yes. Do they both at least have 2 x's? Do they both at least have 3 x's? No. So what's the maximum number of x's I can take? 2. So x squared, not 2x, x squared. Bless you. So to figure out what's left, I'm going to divide each of those, just the first 2 terms, by x squared. If it confuses you with the variables, just think, I started with 3 x's, took out 2. How many x's are left for the first term? 1x, so just x, right? Minus, because a negative divided by a positive is a negative. What is x squared divided by x squared? What? 1. I had 2 x's, I took 2 out. Okay, there's no x's left. So think of 1 as a placeholder. You don't put x there. Anytime you divide a term by itself, the result is 1. In this case, -1, because negative x squared divided by positive x squared is -1. Y'all cool with that? All right, remember, your second group, your GCF, you have to factor out a sign. So the sign you're going to use is whatever the sign of the first term of the second group is. So in this case, it's negative. Okay, 4x and 4. What's your GCF? 4 divides into both terms evenly. There's not a larger number. Do they both have an x? Hold on, do they both have an x? No. So you can only factor out -4, right? So when you divide each term by the GCF, you're not dividing by 4, you're dividing by -4. So what is -4x divided by -4? X, and +4 divided by -4, -1. This is how you know if you can do factor by grouping. If what's inside the parentheses is identical, you can do factor by grouping, okay? So once you know that, you make 2 sets of parentheses. What is inside your parentheses is technically the greatest common factor of your first and second term, okay? So it's like we're factoring it out. That's why you only take one of the x minus 1s. A lot of kids get confused, like, where'd the other one go? The other set of parentheses, whatever is on the outside, you group that together in the other parentheses, your original GCFs. Now, what's in this parentheses? That's a quadratic. Its highest degree is 2. Technically, this is a difference of squares. So I could factor it further. However, my goal is to solve. And so I have a quadratic term. I don't have a linear term. Remember, linear is just x to the first power. So because I don't have both of them, if I set that equal to 0, I can solve it without factoring further. So I'm not going to worry about it. But you could. Its factors are x plus 2 and x minus 2, right? Difference of square. But I can solve it from this point. So once you have your factors to solve, set each factor equal to 0. And how many solutions am I supposed to get altogether? 3. How many am I going to get from x minus 1? 1. How many am I going to get from x squared minus 4? 2, because 2 degrees, right? 2 degrees, 2 roots. X minus 1. 1 degree, 1 solution. X equals 1, correct, because I'm going to add 1 to both sides. X equals 1 is one of your solutions. X squared minus 4, I'll add 4 to both sides. So x squared equals positive 4. Is that my solution? No, because we're not solving for x squared, we're solving for x. So what will I do to get x by itself? No, it's not 2x, it's x squared. What did you say? No, because if I do that, then I'm going to end up with 1 on the left and 4 divided by x squared on the right. Square root. The inverse of squaring something is taking the square root. So if I want to get x by itself and it's being squared, I have to take the square root. X squared times x squared is x to the 4th. Square root of 4 is 2. Correct. So on the right side, I'm supposed to get two solutions. Remember, when you take the square root of 4, you're taking the positive square root and the negative square root. If you forget and just take the positive square root, you're going to get one solution. Remember, x squared means two solutions, two roots, two zeros, right? So don't forget positive and negative. So what's the square root of x squared? X equals, what's the square root of 4? And positive 2 times positive 2 is 4, and negative 2 times negative 2 is 4. That's why it's positive and negative 2. So I've got three solutions. 1, positive 2, and negative 2. Are they all real? Yes. So how many times is my graph going to cross the x-axis? 3, because none of them repeat, right? So is my graph going to bounce at any of these zeros? No. How do you know, Alexia? Okay, and just because it repeats doesn't mean it's going to bounce. It's got to repeat an even number of times. So say x equals 1 was a solution twice, or 4 times, or 6 times, or 8 times, we would know it would bounce at x equals 1. But if it repeats itself 3 times, 3 is an odd number. Multiplicity is odd. It would not bounce, right? You only get a bounce if the solution appears an even number of times as an even multiplicity. All right, so now we know enough. We can start to make our graph. And we know that our y-intercept's at positive 4. We knew that from just looking at the graph. So I know on the y-axis, I want to make sure to include that point because it's a point that I know for sure, right? And I know on my x-axis, I need to go up to at least 2, if not further. And my smallest x value is negative 2, so I at least need to go to negative 2 on my x-axis. My y-intercept was 4. Did I get that by solving something? Your y-intercept? No, we could, that was the constant, right? We didn't have to do any math to find the y-intercept. We did the math to find the x-intercepts. So let's plot those. X is equal to positive 1. X is equal to positive 2. And x is equal to negative 2. Everybody cool so far? So once I plot my x-intercepts and my y-intercepts, then I'm going to look at my end behavior, down and up. The left side of my graph is going to point down. The right side is going to point up. So I'm going to go to the 0 furthest to the left and draw an arrow pointing down. And I'm going to go to the 0 furthest to the right and draw an arrow pointing up. So from there, we pretty much sketch what's in between, right? But my graph is going to curve in between each set of consecutive x-intercepts. So I'm going to have a curve between negative 2 and 1. I'm going to have a curve between 1 and 2. Now, between negative 2 and 1, my y-intercept falls between those 2 points, right? So I know that I at least need to go high enough to pick up that y-intercept. And then I don't know any y values between 1 and 2, so I'm just sketching. I don't really know how low that's going to go. I would have to do more math, or I would have to use graphing technology. So what's in between is just a sketch. And like this 4, your graph might even go higher than the 4 before it turns to come down to the 1. Or it might have gone higher than the 4 before it turns. I don't know. It's a sketch. But I do know it's going to cross the y-axis at 4. So I need to make sure I include that in my graph. Coolio? So everything is the same about everything that I've taught you on the last 3 lessons. The only thing that's different is how you find the x-intercepts. And that just depends on the problem. If you have 4 terms, you want to try to solve it like we're doing right now. Coolio? All right, example 2. Now look, on example 1, I had 4 terms, but my highest degree was 3, okay? Well, of the problems I'm going to give you, your highest degree is either going to be a 3 or a 4. So in my next example, my highest degree is going to be a 4. Oh, and also, if any of my terms were imaginary, or I'm sorry, any of my x-intercepts were imaginary, I know those are still solutions, but I wouldn't see them on the graph, right? Yes, Ms. Freeland. So we're going to graph x to the 4th plus 5x cubed minus 2x squared minus 10x equals 0. Yes? I do? Sure. You're welcome. It'll be on bulletin. It's not a handout. Okay, so the way I taught you to do this the other day, when you have 4 terms, right? So I taught you how to just start by factor by grouping. But then once you get to a certain point, and once you find your factors, then you're going to have another GCF in there that you have to factor out. And that was, I think some of you are confused by that. So what I'm going to show you today, which you can do that, it's fine. But a lot of kids forget at that point and it's confusing. So what I'm going to show you today is, let's factor out the GCF from the beginning, okay? And then hopefully that will solve some confusion. Because I still have 4 terms, right? Do all of my terms have a greatest common factor? All 4 terms. They don't? They all have an x in them, don't they? I've got 4x's here, 3x's here, 2x's here, 1x here. Don't they all have an x? So can x be a greatest common factor? Heck yeah. All right, so we're going to do that first. But before we start, let's say some things about our graph. What is the y-intercept going to be? 0. It's not the question I asked. How many how many degrees do we have? 4 degrees. So we're going to have how many roots or zeros? 4. But it doesn't mean they're all going to be real, right? If they're any imaginary, we won't need those on the x-axis, only the real ones. But we can have 4, no more than that. In behavior, my problem's in standard form. The first term is x to the 4th. Is my exponent odd or even? Even. Is my coefficient positive or negative? Positive. So even positive is what? Up and up. Up and up. So again, I know all of those things about my graph without doing any math. That's just what we know. If we had a multiple choice test, I could probably rule out a couple of your options by knowing these things, right? Even without doing any math. But we're not having a multiple choice test. So you have to know how to find one of the really important things, which is the x-intercept. Okay, that's why we have to do the math to find the x-intercept. So we've got 4 terms. I am hoping, I'm going to rewrite down here. 4 terms means that we hope to solve doing factor by grouping. And I could go ahead and group my first 2 terms together and my second 2 terms together. And we could do it that way. But like I said, that causes a little bit of confusion a couple steps later. So if I notice there's a greatest common factor to begin with, I'm going to go ahead and factor it out. All right. We already said it was what? What's your GCF? X. I'm not doing any grouping yet. I'm just taking out the GCF from the beginning. I either got to do it now or I got to do it later. Right, Brian? Can you also keep that face going? All right, so what's x to the fourth divided by x? X to the third, which is also x cubed. What's positive 5x cubed divided by x? Positive 5x squared. Good. What's negative 2x squared divided by x? Negative 2x. What's negative 10x divided by x? Negative 10. Now, what's inside parentheses? If I set that equal to 0, I can't just solve for x because I've got 3 terms that have an x in them. Okay, to be able to solve for x, I can only have 1 term with an x in it. Well, notice I still have 4 terms inside the parentheses, right? So I'm still going to try to do factor by grouping on those 4 terms. So this x on the outside, that is a factor. It's a variable too, so it's going to give me one of my solutions. So don't forget about it. But I'm going to make parentheses. So what's the GCF of the first 2 terms? X, what? X squared, because we're not looking at the original anymore, right? We're looking at what was left after I factored out the GCF from everything. So I'm just going to factor those first 2 terms by x squared. What's x cubed divided by x squared? X. What's positive 5x squared divided by x squared? What? Plus 5. Positive 5. All right. What's going to be the sign of the GCF of the next group? The sign. Negative, because that's the sign of the first term of the second group. And what's the GCF of the second group? 2. And remember, if there's not anything other than 1, then you got to take out a 1. But we can factor out a negative 2. So I'm going to divide each of those second 2 terms by negative 2. What's negative 2x divided by negative 2? X. What's negative 10 divided by negative 2? Positive 5. Is what's inside the parentheses identical? Yes. So I can use factor by grouping, okay? So don't forget you had that GCF on the outside. You just keep bringing it down. It does not go away. If you forget about it, your graph's not going to be right. And then I'm making 2 sets of parentheses for what was in the brackets. What am I going to put in one set of parentheses? X plus 5. What am I going to put in the other set? X squared minus 2. Now, x squared minus 2, x is being squared, that's a quadratic, but since I don't have any other terms with the x, I can solve for that. I don't need to try and factor it further. Okay, how many solutions am I supposed to get altogether? 4. How many am I going to get from the factor of x? 1. How many am I going to get from x plus 5? 1. How many am I going to get from x squared minus 2? 2. So 1 plus 1 plus 2 is 4, right? If you forget to bring that GCF down, you're only going to get 3 solutions. That should be a hint, like, okay, I lost something somewhere because I'm supposed to have 4, okay? So now that I've factored, set each factor equal to 0. So x is a factor, set it equal to 0. There's one solution. X plus 5, set it equal to 0. If I subtract 5 from both sides, x equals negative 5. Is that imaginary? No, because I'm not taking the square root of it, right? Kayla, can you put your phone in your backpack, please? How many solutions am I going to get from x squared minus 2? We already said 2 solutions. So I'm going to add 2 to both sides. X squared equals 2. Now what? Take the square root of both sides, and remember to take the positive and negative square root of 2. So the square root of x squared is x equals, is 2 going to give me an imaginary solution? No. Do I know where the square root of 2 is on my graph? No. So I'm going to find a decimal form, right? So I'm going to put that in my calculator. 2 square root, I'm going to go with positive or negative 1.4. So that's 2 solutions. Coolio? So am I ready to graph? Yeah. Do any of my solutions repeat themselves? No, they all only occur once, right? So there's not going to be any bouncing. I don't have to worry about any bouncing going on. Nothing's going to repeat itself because they all only occurred one time. And I know my y-intercept was 0. And I know my 4x-intercept. So I'm going to draw my graph, keeping those numbers in mind. And I know my x-intercept's the smallest one's -5. So at least need to go down to -5. And my largest is positive 1.4. So I'll just go to 5 on both sides. No, I'm out of room. I'll go to 4. All right, y-intercept was 0, and my x-intercept, I had an x-intercept at 0 too, so those points are the same. I also have an x-intercept at -5, at -1.4, and at positive 1.4. Y'all cool with that? And behavior was up and up. So the far left side, I'm going to go to the far left 0, do an arrow up, and the far right 0, do an arrow up. We got to have curves in between each set of consecutive zeros, right? So at -5, am I going to bounce at -5 or cross the x-axis? Cross it. And I'm going to go down. I don't know how far, but I know I got to come back up when x is -1.4 because that's the next 0, correct? Am I going to bounce at -1.4 or cross the x-axis? Cross it, and I got to go up. I'm not sure how high, but I got to turn at some point to come back down to get to the next 0. Am I going to bounce at 0? No, and I don't know how low I'm going to go, but I'm going to curve at some point because I got to come back up to get to the next 0. Right on? There's your graph. Let me just show you real quick how I taught y'all how to do this last time. I don't care which way you do it. I just want to show you both ways. So when I taught you this originally, I didn't have you factor out the GCF from the beginning. Okay, we didn't do that like we did this time. So I'm going to show you what to do if you don't factor it out and how you get the same thing. So if you don't factor out the greatest common factor from the beginning, group your first 2 terms together, group your second 2 terms together. What's the greatest common factor of my first 2 terms? X cubed. So I'm going to factor an x cubed out of these first 2 terms. What's x to the 4th divided by x cubed? X. What's 5x cubed divided by x cubed? 5, and it's positive, right? What's going to be the sign of the next GCF? Negative. And what is the GCF of the second 2 terms? X is part of it. -2x, because 2 divides into 2 and 10 evenly. It's the largest number, and they both have at least one x, right? So I'll factor out a -2x from both of those terms. So -2x squared divided by -2x is positive x. -10x divided by -2x is positive 5. So what's inside parentheses is identical. So we're going to group them together. The x cubed minus 2x I'll put in one set, and the x plus 5 I'll put in the other. I could have put x plus 5 in the first set and x cubed minus 2x in the second set. It doesn't matter. Multiplication order doesn't matter, right? So here's the difference. Once we get to this point, this term has two terms and they both have an x. If I set this equal to 0, I'm not going to know what to do to get x by itself because I've got x cubed and negative 2x. Notice these two terms have a GCF, right? So we didn't factor out the GCF from the beginning. It's showing up now. So if you don't do it at the beginning, like we did originally on this problem, then you've got to do it now. One or the other, it doesn't matter. The reason I showed you the first way is because a lot of times kids get to this point and they don't realize I got to factor out a GCF and they get confused, okay? But either way, they both take the same amount of steps. What is the greatest common factor of this first group? Anyone? Do they both have an x? How many x's can I take out? One x. Coefficients, I've got 1 and negative 2. Does anything divide into 1 and negative 2 evenly besides 1? No, so my GCF is x. I'm only factoring that out of the first group. That second group didn't have a GCF. So x cubed divided by x is x squared. Negative 2x divided by x is negative 2. Aren't these the same factors that I ended up with up here? X plus 5, x minus 2. Same factors, right? So either way you want to do it, whatever makes the most sense to you, I'm fine with, as long as you show me your math to prove it. So on your assignment today, you're going to have all problems will be either like this one, where your highest degree is 4, or like the first one, where your highest degree is 3. We're doing factor by grouping on all of them. I'm giving you like 4 problems. Okay, that's it. You have to show me your math. You have to make sure your graph is labeled appropriately. I want to see, you don't have to label all the numbers, but you need to label at least, like I could have put a 1.4 there, at least where the graph crosses the x and y axis, I at least want those numbers labeled. And you have to show me how you found the x values, okay? Anybody have questions about that? All right, so for those of you at home, I'm going to stop the video and then I will post the assignment on Schoology. Also, if this was not enough examples for you, the whole video of the whole entire lesson that I had taught previously is still on Schoology. It's called Graphing Higher Degree Polynomials, Factor by Grouping. There's 3 videos that sound the same. They're all graphing higher degree polynomials, but you got factor by grouping, factoring out a GCF, or I think I called it basic factoring, and sum and difference of cubes. All right, today, this video is graphing higher degree polynomials, factor by grouping. Coolio?